Prajwal? Prajwal? Are you around, Prajwal? Hey, Prajwal.
Yes, start. Already 100 is there.
Yeah. Hello and good morning, everyone. Dear students, hope I am audible to all of you. Again, I'm trying to basically allow you to unmute with an understanding that you will not really have much noise when you are talking to me, and you all sit in a place where there's less noise. All right, so that there can be interaction and we can really have a wonderful session. But this again will depend on how good you people are in managing your mics. Okay, if I find that it's creating a lot of disturbance, I'll be taking away that particular option for you. Again, reminding you of this program is again sponsored by Dayanand Sagar University. They are the ones who is organizing this in association with Dhanadhara Educational Services. We are the ones who are basically giving the academic input, but it's the Dayanand Sagar University which is presenting this program. Okay, this is in fact a free online program. I think we should be really thankful to them for providing an opportunity for both the teachers and also the students. Today's topic is going to be two-dimensional motion. By the way, am I audible? Is the board visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you.
Yes, sir.
Thanks. Okay.
Yes, sir.
Now in the two-dimensional motion, we will try to actually revise few preliminary things first and then go to projectile motion. Essentially, 2D motion will have projectile motion and the circular motion. But before that, there are certain preliminaries to be understood. Two-dimensional motion essentially is two independent one-dimensional motion. Okay, you can consider that there will be a motion along the x direction as a function of time. There will be a motion along the y direction. It can be even yz or xz or anything, but 2 dimensions is what the motion is going to be. And now we always want to find out what will be this y as a function of x. So in any 2-dimensional motion, you will be coming across these 3 aspects. You should know how to represent the x direction motion in terms of time, y direction motion in terms of time, and also you should know how y is varying as a function of x. The third one is called as the equation of trajectory. This defines how the path taken by the particle is going to be. And it's quite important, students, to realize that the third one is something that we have not done. We already done x versus t in the yesterday's class. Y versus t is also similar. That also is something that has been done. Okay, but it's y versus x that needs a little understanding. So let's look at it. This, in fact, NCERT book has given an extremely nice explanation of it. And therefore, I feel that this is going to really be important for your CET. Whatever is there in NCERT, make sure that you go through it, because they are the ones which will be quite, say, more times repeated in the examination, especially in CET. So some of you might have missed out on this. So let me take you through this in the next maybe 1 or 2 minutes. If I say that there is a particle which is moving as given by this path here, which is a graph of y versus x, this path is called trajectory. Okay, this is a trajectory. The particle is moving like this. Now, if I want to find out the position of the particle, what I will do is the following. I will mark this and then call this as R1. And if the particle moves after a while here, then this becomes R2. Now, this is your delta R. I had told you about this yesterday also. This is your delta R1, R2 minus R1. You should always know that velocity will be decided by this delta r, not by r1 and r2, but rather together r2 minus r1 is what your delta r is. So how is the velocity? Velocity will be always along this point. Now, if you make this delta t smaller and smaller, then we know that v can be written as dr by dt. Now, where will this dr by dt represented? It will be represented as a tangent drawn at that point. So this will be along the tangent drawn at that point. Okay, very, very important idea. I'm writing it down again because this is something where I've seen many times the questions coming on this idea itself. So therefore, I'm writing this curve again. And let me say I want to find out the velocity at that point. Just draw a tangent at that point. Velocity will always be in that direction. Okay, so along the y-x plane, where is the velocity direction? Will be along the tangent. Very important idea. Secondly, where is the acceleration? How do I find the acceleration? Acceleration will be delta v by delta t. Now, acceleration generally will be acting along some line here like this, A, which will make an angle theta, Now, this theta value can be anywhere between 0 degree to 180 degree. It can vary from 0 to 180 here. There are some special cases, okay? Case 1. If theta is equal to 0 degree, then it is said to be an accelerated motion. I told you about this yesterday's class.
Yes, sir.
If theta equals 180 degree, then it is a decelerated motion. Okay, even in two-dimensional motion. All right. Third case, if theta is equal to 90 degree, I think I'll take away your option of switching on the mic if this goes on for another few minutes. If theta is equal to 90 degree, then it is said to be circular motion. In an XY graph, acceleration will be represented by some angle with respect to velocity, but velocity will always be along the tangent. Keep this in mind. Very important idea. Okay. So this is the preliminary that I wanted to basically tell you about in the two-dimensional motion. But generally, how do we analyze a problem in two-dimensional motion? What I'll generally do is I'll take x-axis and y-axis and try to actually look at how the x variations are. X will be given as ux into t plus half ax into t square. Y will be given as uyt plus half ay t square. Two independent motion. Just analyze it in that way. So Vx will be equal to ux plus ax into t. Vy will be equal to uy plus ay into t. This is how I'm going to generally analyze the problems in the two-dimensional motion. Do it along x and y axis separately, then you can actually achieve all the things. Now, if you are all okay with this, I'm going to the next page. If you all have written down this part.
Wait, sir. Wait.
Yeah, I'm waiting.
Worth.
Thank you. Okay. Now let us look at. Let's look at the next idea. The next idea is going to be on the projectile motion. We'll be basically dealing with three kinds of projectile. Okay, but in all the projectiles, we are going to basically look at few things. So I'll take up one by one. I will look at the first one is called as the ground to ground projectile. Okay, ground to ground projectile. In this ground to ground projectile, you will find that if you project the particle with a velocity u at an angle theta, then it will basically have a motion like this. Okay. If I call this as x-axis, this is y-axis. Now you will find that the initial velocity here can be resolved into u cos theta and u sin theta. U sin theta. Now at any point here in the projectile motion, you will find that the velocity here will be given by the tangent drawn at that point. The acceleration will always be downward, which will be equal to g. Look at it, these two will make an angle here, theta. Now at different points, you will have the velocity and the acceleration making different angles. Just to give you a comparison, in case of circular motion,
Sir, audio.
You will always find that this angle theta will be same, which is 90 degrees in circular motion. But in the projectile motion, this will keep changing. This will keep changing. You'll find that theta 1 is obtuse. That is, before attaining the highest point in the trajectory, theta 1 is obtuse. Theta 2 is equal to 90 degree at highest point. At highest point, theta 3 will be acute angle. Acute angle. That is after maximum height attained. Maximum height attained.
Sir, nothing is audible.
Is that the case with everyone?
No, sir. I can
No,
hear
sir.
you.
No, no, sir.
Okay. Then please check your system. Go to place where you have good say connection, and then you will be able to manage it.
Sure.
Okay. Okay. Go to a place where there is good signal. Then it will improve.
Yes, sure.
Moment you are done with your speaking, you need to mute your mic. Otherwise, it's going to unnecessarily create noise everywhere. You don't want that to happen, isn't it? Yeah. So this is something that you all should realize. Now, in this part, I'll be interested in the range. The range. You all know what range is. This particular distance is called range along the horizontal. So this range will be given as 2u square sine theta cos theta by g. I would like to write it in this particular expression because it helps me in solving the problem quickly, and therefore write it in this way. Another way of writing this, of course, is u square sine 2 theta by g. By g. So both of them will be important. Okay, note down that. The third point of interest here is what is called as the maximum height attained by the projectile. Okay, this is the height here that is shown. This height is what refers to as the maximum height. Maximum height. This h you can write it as u square sine square theta by 2g. By 2g. This is the maximum height attained by the particle. I should have done this as the first one, but nonetheless, we will write down this. This is called as time of flight. That is the time taken for the entire journey from the ground again back to the ground is called time of flight. This time of flight will be equal to 2u sine theta by g. There is no scope, there is no time for deriving all this expression, nor there is a need at this hour. And therefore, we will actually skip this derivation, but write down the important formulas that you always get in this.
Sir, that is u square, no, sir.
Which one?
2u square sine theta by g.
No, that's 2u sine theta by g for time of flight. Okay. Now, in this particular case, there are a few things to be noted down. Note number one. Note number one.
Sir, please explain equation of projectile.
Sorry,
Equation of projectile.
I will do that. Just give me a minute. No, I'm basically giving you note one by one. I will do. Just give me a little time for completion. No, Good that you reminded me of this. Theta is equal to 45 degree. We say that the range will be maximum. And what is that range given to be? The maximum range given to be? Maximum range will turn out to be u square by g, isn't it? Remember this, very important. The maximum range will always be u square by g. When theta equals 45 degree, what will be the height, maximum height attained by the particle? This will be equal to u square sine square 45 by g by 2g. So this will turn out to be u square by 4g, or this will be equal to r max divided by 4. When you have maximum range, height will only be 1/4 of the range. I'm sure you all would have done this in the first year. I'm only trying to recollect all these ideas so that you will be quick in answering MCQs. All right, that is the intention. Note number two. Range will be same for angle theta and 90 minus theta. Okay, that is, if R1 is the range for some velocity, okay, for a range of 20 degree, then R2 is the range for 90 minus 20, which is equal to 70 degree. Then we know that R1 and R2 are same. Okay, though you project at different angles, they both in fact will have the same range. Very interesting idea. So you're launching at a smaller angle, you get a certain range here. You launch at a higher angle, then it goes to a higher one, no doubt, but again comes back to the same point here, and then reaches this point. So R1 will be same for both of them, for 20 degree and 70 degree. Now, so the point to be noted there is a very important one. When you have in fact this particular case to be satisfied for theta and 90 minus theta, what will be the ratio of the time of flights? This will be equal to, see, everything is constant except sine, right? So this becomes sine theta by sine 90 minus theta. And sine 90 minus theta is cos theta, and therefore this turns out to be tan theta. So what will be the ratio of the time of flights in the two cases? Tan theta. I'm sorry, students, I'm taking away your right to actually unmute yourself because you're not using it very responsibly. Okay. This is what happens if you don't do things responsibly, right? So you keep actually switching on your mic when not needed. Next point is, what will be the ratios of the height when this particular thing is satisfied? H1 by H2. This will be again equal to sine square theta by sine square 90 minus theta, and therefore this will be equal to tan square theta. So what will be the ratio of the height? Tan square theta. What will be the ratio of the time of flight? Tan theta. This happens only when the ranges are same. Ranges are same. This will be a question that will be generally posed to you. So therefore, keep an eye on this. Very nice. Third point to be made is, when is height attained maximum? For what angle do we get this? We'll get this for theta equals 90 degree. Then h will be equal to u square by 2g. This basically is vertically projected object. Okay, this vertically projected one. If you throw it at theta equals 90 degree. Can I now move on to my next page? Have you all written down what is required? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
I'll now go to my next page with next idea. Same thing here. I need to give some more points for you here. So I'm basically going to the next page to give you the fourth point here. Someone asked me about the trajectory equation. The trajectory equation is y is equal to tan theta x minus gx square by 2u square cos theta. This is one form of it. There's another interesting form which will also be very useful for your solving the problems, is x tan theta into 1 minus x by 1 minus x by. These two are very important trajectory equations.
Sir,
that you
it's
need to
cos square
understand.
theta.
Correct. Thank you. Cos square theta. Very good. Very nice.
Thank you, sir.
Now, as a fifth point, I want to give you about one more thing. Okay, look at it. If I have the motion basically to be like this, at every point you can find out what will be the velocity of this. This velocity will make an angle alpha with respect to the horizontal. Let's call this as V cos alpha, and let's call this as V sin alpha. Now, V cos alpha can be shown to be U cos theta, where U is the initial velocity, making an angle theta here. So this will be your U cos theta will be equal to U cos theta. V sin theta, on the other hand, will be equal to U cos theta minus GT. T is the time taken to reach this particular point. So alpha here, I'm so sorry, V sin alpha. So V cos alpha, V sin alpha will be given by this. At any instant of time, the velocity of the projectile, therefore, will be given as V cos square alpha square plus V square sin square alpha. You can show that this will be equal to U square plus G square T square minus 2U sin theta into GT. So this is what we can show the velocity at any instant of time to be given us. Remember, if with this expression, if you can, or remember these two ideas. That should be good enough to solve the problems on ground-to-ground projectile. Okay, that is what I have done here. Okay, what is the second kind of projectile that we all know about? This is called as horizontal projectile. Horizontal projectile. Okay. Now, horizontal projectile is something where you launch it from a height, from a tower or something, with a horizontal velocity. So initial velocity will be equal to ux. Only will be along, rather ux is equal to u naught. Uy will be 0 in this case. Uy is the initial velocity, I mean. So it's going to come here like this, and then fall off to the ground because of gravity, and this will be your range. This will be a range. The height from which the body is thrown, let's take it as h. Let us take it as h. Now, at every point, look at it, the velocity again will be given by the tangent drawn at it, and the acceleration will be downward. Okay, so will be downward as usual, as you got it in the previous case. Now here one can show that the time of flight is given to be 2h by g. Okay, 2 capital H by g. That is the time of flight. Similarly, you can also show that the range will be equal to u naught into root of 2h by g. 2h by g. So the range has a different expression here. Time of flight has a different expression here. Please make a note of it. All right. Very important idea, and one should not forget this. Similarly, I can also talk about Vx. Vx here will be equal to u all the time. Vy, because I'm basically resolving this into two components. One is your Vx, the other one will be Vy. So Vy will be equal to GT, and it's in the minus direction, negative direction. Therefore, I am attaching minus sign. So what will be the net velocity here? Therefore, it will be equal to Vx square plus Vy square, and hence will be equal to root of u square plus gt the whole square. Okay, that will be the expression for velocity. Velocity, when I write here, is not written as a vector, is only the magnitude of it. But relative angle can be always obtained. So this is about what is called horizontal projectile, and I have also given you all the important ideas that corresponds to this. If you all have written down this, I'll be happy to go to my next idea.
Yes, sir.
Yes, sir. Yes, sir.
Done, sir.
Yes, sir. Yes, sir.
Am I fast? Are you all okay with my speed today?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
And also at this point, I would
Sure.
like to tell you that we have shared all the worksheets with Dayanand Sagar University faculty. So they will be giving you these worksheets either by mail or they'll put it on their website. Please contact them. They will let you know.
Got it. Got it.
You got it already?
Got it, sir. Yes, sir. Yes, sir.
Class, wonderful. I think we should really be thankful to DSU for all the things they do. They are so quick in communication. They've already given you the material. So it's very nice of them. The next part is what is called as the oblique projectile from a height. From a height. This is like combination of ground to ground plus horizontal. Both put together, this particular case comes up. Remember, there is no straightforward formulas for this, but rather you will find that you will have the particular case has to be obtained and then resolved. So, but there's nothing like you can actually give a straightforward formulas for this part. So therefore, I thought I'll tell you how to deal with this, because few times these questions have come in CET, and when these questions come, they're generally supposed to be little on a harder side. Okay, but then nonetheless, we need to know how to solve them. To become better than others, you should always know how to solve tougher problems. All right. So let's say that I'm going to project a projectile from an angle theta from this height h. So it will now have u cos theta along the horizontal. It will also have a component of u sin theta along the vertical. Lalit Sagar, anything, any issues? What do you want to know? Okay. Okay, fine. Now the projectile trajectory is going to be like this. It will come and fall here onto the ground in this way. Now this is called range. Now, and there will be time of flight, there will be maximum height attained, and so on and so forth. But how do we really analyze a problem like this? Now take it one along the x-axis, the other one along the y-axis. Let's try to solve this problem along the two directions and then combine them whenever necessary. Ux will be equal to u cos theta. Ax is 0. And therefore, you will find that the range will be equal to ux into time of flight, t. Okay, which will be u cos theta into t. The whole problem is to find out what this time of flight is. There's no straightforward relation to it. Let us see how to solve it though. Uy will be equal to u sin theta. Ay will be equal to minus g. And therefore, I will say that minus h, that is to travel to the distance minus h, will be equal to u sin theta t minus half g t square, where this t is what your capital T is going to be, the time of flight. Time of flight. Okay. Now you have to solve this equation. Solve this equation, which is going to be a quadratic equation, and get t. Now, once you get t, substitute that in the range and get the expression for the range. So this is how one has to actually solve a problem in case of the oblique projectile. I think I should take an example so that this becomes clear to all of you. Let us say that I have a projectile which I'm going to project with a velocity of 40 meters per second at an angle of 37 degree. Then I can write down that uy, also from a height, I should mention, no, height of 100 meters. Height of 100 meters. So now, how do I find the time of flight? I'm going to use this expression. Minus 100 is equal to 40 sine 37 t minus half 10 t square. Look at it, I know most of it now. Sine 37 for your kind information is 3 by 5 into t. If you don't know about this, please refer to any standard book. You will know why you will have this to be 3 by 5. Now I get an equation here as minus 100 is equal to 24t, 24t, 5 1s are 5 8s are 8 3s are 24, 24t minus 5t square. Or I can write this as 5t square minus 24t minus 100 is equal to 0. I do once in a while problems here itself because you should also know how to do things quickly, right? So I thought I should always give you an idea for this. This becomes 24 plus or minus root of 24 square, whatever that be, okay, minus, that becomes basically plus now because it's minus 100 plus 400, 400 into 5. So that becomes 2000 almost divided by n. So from this, you can find out what time is. Do that later. Don't worry about the simplification part of this. You get the time. Once you get the time, then R can be written as 40 cos 37.
Sir, it's minus 2000.
Why minus 2000?
In
Minus
place
4
of
Minus
AC.
4 AC.
Minus 4 AC. There's already a minus sign here. No, with C.
in place of 200, 2000 has to come.
Yes, sorry.
That's all. But plus is all right. Okay. So therefore, you get time here. Once you get time, you just have to substitute for the time in this expression and get the answer for range. I thought I should tell you this method because problems may come on this idea as well. Okay. Are you all okay with this? Can I go to my next idea in this one?
One minute, sir.
Yeah. Please write down. Please write down. No issues at all. You will get time. Don't worry. Can I go to my next idea then? I'm waiting for you all.
Done, sir.
Thank you.
Done, sir.
Okay, nice. Can you please keep your mic off? Though it's actually nice to hear this call of the hen, but this is not the time. So the next one that I'm going to deal with is on a little higher side. Please look at this. This is called as the radius of curvature of the trajectory. Okay. Now you may be wondering as to what this idea is about. If you consider ground to ground projectile like this, now you'll find that at the topmost point, the velocity will be like this, which will be equal to u cos theta. Now, if you look at the acceleration, A will be equal to G in this way. And look at the angle between them, they are 90 degrees. If B and A are perpendicular, then what kind of motion will there be? There will be a circular motion. And therefore, I can say that this will be part of a circle. This will be part of a circle of radius R. Now, what will that radius R be equal to? This is the radius of curvature, not the range, all right? Radius of curvature. Maybe I'll call it a small r just to remove the confusion. Small r. Then how do I find this small r? Very important idea. Remember, you always say that acceleration will be equal to v square by r in circular motion. Am I right? V square by r. And therefore, r will be equal to v square by g in this case. V square is nothing but u square cos square theta by g. Right. So this in fact is the expression for the radius of curvature at the topmost point. Generally, you will be tested at the topmost point. So I'm only giving you expression for that now. Sorry. Now, after this, I'm now going to another idea. I'll go to my next page. If you're all okay with this, can I move on to my next page? This is called projectile on an inclined plane. On an inclined plane. Since we are not deriving it, I thought it's worthwhile to give you this expression because sometimes in the NEET examination, I have found this question coming. So I thought I should really, therefore, give you this idea. Let us say that I have the angles that are given to me are this angle alpha of the inclined plane, and this angle given to be theta, Okay, then the expression for the range. So this is going to be a projectile like this. It will come and hit the inclined plane like this. This will be the range of the projectile now on the inclined plane. Remember, this will be the maximum height attained, and there'll also be time of flight. Time of flight will be equal to 2u I think I will make this diagram a little different. Okay, I will make this diagram a little different so that I will get a much simpler expression to deal with. So sorry about this. I will basically make this diagram a little better. Okay, then it's going to be easy for you to analyze. Okay, this is the inclined plane. Let's say that this makes an angle theta with respect to the horizontal, and then I'm going to throw a projectile here in such a way that this angle here makes an angle alpha. Alpha is again the velocity with respect to this, and this is going to come and basically fall onto this here, and this will be the range. Now, how do I find the time of flight? Time of flight will be given as 2u sine alpha minus theta divided by g cos theta. Look how different the time of flight is now for the projectile on the inclined plane. Very, very different, isn't it? Range of this will be equal to u cos alpha into 2u sine alpha minus theta divided by g cos square theta. G cos square theta. Very interesting. This in fact is the expression for the range, okay, of the projectile on the inclined plane. In fact, I can write this as together 2u square cos alpha sine alpha minus theta divided by g cos square theta. This is the expression for the range. Now, this we call it as inclined plane up the incline. That is, it is trying to climb the incline. Similarly, we can also think of a projectile which is supposed to be projected from this particular angle. Let's say that down the projectile, this is what will be given by the relation. This angle, let me take it as theta. This angle, let me take it as alpha. Okay, I'm defining all the things here again. Please remember, this is the range of the projectile. You will find now this is called down the projectile, down the incline. Projectile is projected down the incline. So the time of flight here will be equal to 2u sine theta by g cos alpha. Okay, G cos alpha. The range will be given as 2u square sin theta cos theta minus alpha divided by G cos square alpha. G cos square alpha. I have defined alpha and theta correspondingly for this as well. Okay. Important ideas again. Please make a note of it. You will find that this will be very useful for solving problems quickly, especially of the little higher order. Okay. This will not be asked on all the occasion, but certain cases you will be actually finding this to be useful. If you all have done with this projectile on the incline plane, I would now like to take you to another part of it, which is the circular motion. Can I do that, please? Can I go to that? Only the kinematics part of circular motion, we will do it today. We will not do all the part of the circular motion. Only the kinematics part, we will try to do it today. Can I go to my next page? Are you all done with? Can I go to my next page? Oh, I have not allowed you to unmute, is it? Okay, fine. Let me allow for some time and then see how you
Yes,
are.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now mute your mic immediately. Mute your mic. Mute
Okay,
your
sir.
mic. Yeah.
Okay, sir.
All of you should do that. Now I'm going into another kind of circular motion, which will be another kind of, say, two-dimensional motion, which will be circular motion. Now here also you will find that when the particle is moving in a circle of some radius r, you will find that every time the particle here will have the y and the x coordinates. If you consider this to be your origin, this to be your x-axis, this to be your y-axis, you will find that x will be a function of time, y will be a function of time. And therefore, this is a two-dimensional motion. Two-dimensional motion. But the way we are going to actually express the motion will be in terms of r and theta. We call this as the polar form. Okay, I will try to express everything in terms of r and theta. But mind you, r will be a constant for a given circular motion. So what will vary is only angle. So theta is the only variable in case of a circular motion. Now, what do I write this theta as? Now, this theta, one should always know, is measured in terms of unit called radian. And I hope you all know how to convert radian to degree, degree to radian, okay, or degree. Sometimes we also give it in terms of degree. Now, 1 radian will be equal to theta in degree, okay, into pi divided by 180 degree. Okay, same way, 1 degree will be equal to, or theta in radian, let me say here. This also I say theta in degrees will be equal to theta in radian into 180 divided by pi. Very good. So this is how I'm going to basically measure the angle theta. Now, Prajwal, if you are around, I will have a request for you.
Yes.
Whenever basically student answer, no, maybe
Okay.
after a minute or so, unmute everyone.
Yes, sir. Okay.
Thank you so much.
Yeah.
So theta is measured basically in radian. Now this theta is something which can vary. And therefore, I'm going to define what is called angular velocity, which will be omega equal to d theta by dt. All right. Omega will be in the direction of the change of the angle. Omega will always be along the axis of rotation. Axis of rotation. Let me help you to understand this. If you say that there is a circular motion like this, okay, in this way, this is in the horizontal plane. In the horizontal plane, you all should understand this horizontal plane, which is perpendicular to the plane of the book right now. Okay, then if the rotation is in this particular way, then the angular velocity will be represented like this. No. Okay, will be represented like this. Because this theta motion is along the anti-clockwise direction. Anti-clockwise, then omega is taken to be positive. Positive is upward. Now, same way, if I have the circular motion where the motion is along the clockwise direction, then omega will be along the axis of rotation. Look at it in this way. Omega will be downward now. Downward. But both the cases, it's along the axis, one upward, the other one downward. So here, since it's clockwise direction, omega is taken as negative. Okay, very important idea. Please make a note of this and then keep it with you. The third part is called angular acceleration. Angular acceleration will be defined as alpha is equal to d omega by dt. Now this alpha also will be along the axis. We'll consider the same kind of convention here also. If the motion is actually, if the angular acceleration is in the anti-clockwise direction, then alpha is taken to be positive. Okay. Clockwise, alpha is taken to be negative. Okay. If you all are done with this, I want to go to my next part.
1 minute, sir.
Yeah.
Done, sir.
Very nice. So can I go to my next part then?
Yes, sir.
Thank you. I'm now going to equations of motion. Now you'll find to your surprise that the equations of motion is going to be same if alpha is taken to be constant. Alpha is the angular acceleration. I can always say that angular velocity after a time t can be written as omega naught plus alpha t, which is very similar to v is equal to u plus at. But now everything is written in terms of angular measurements, that's all. And then you will also find theta to be equal to omega naught t plus half alpha t square. And this is very similar to s is equal to ut plus half a t square. And then you will also have omega square equal to omega naught square plus 2 alpha theta. Okay, and mind you, all of them again are vector equations. But only advantage here is going to be that the sign that theta, alpha, and omega can have either is positive, negative. That's all. Only two possibilities. There is no other possibility here. So therefore, it's easy to always deal with. But this is the equation of motion that one should basically look at. Now, you will also find this relation to be useful. If basically body is in a circular motion, circular motion, then let us say that it is basically revolving in an orbit of radius r, and it has a velocity here equal to v. Then you can show that for a particle here like this, it would travel some point here like this, and the velocity would again become tangential here like this, v. Now this is S. You can prove that S will be equal to r theta, where angle theta is this. Similarly, you can also prove that V will be equal to r omega, where omega is the angular velocity of this. V is the tangential velocity here, or the velocity of the particle. Okay, will be equal to r omega. And then you can also show that A, the tangential acceleration A, will be equal to r alpha. This is something that you can always show. Now in a circular motion, apart from tangential acceleration, there will also be radial acceleration. Now, whenever I say radial acceleration, I mean it will be towards the center. This radial acceleration will be equal to v square by r, which is known as the centripetal acceleration. Okay, so for a body in a circular motion, we'll have two kinds of acceleration. Okay, one is the radial acceleration, the other one is the tangential acceleration. So what is the net acceleration of both of them? The net acceleration will be equal to root of at square plus ar square. This will be the net acceleration. Okay, at this point, I want to tell you all that we will be coming across two types of circular motion. We'll be dealing with circular motion whenever we take up the chapter corresponding to that. Okay, here I'm only doing the kinematics part. In the next class, when I do Newton laws of motion, I'll be taking the circular motion corresponding to the dynamics of circular motion. Again, when it comes to energy of it, I'm going to deal it with in the chapter on work energy. Work energy principle. There, when I teach the chapter there, I will look at the circular motion at that point. Now here, two types of circular motion that you can think of is uniform circular motion and non-uniform circular motion. Now, when do we say something circular, uniform circular motion is when we say
velocity remains constant.
Correct. Alpha is equal to 0, at is equal to 0, and therefore the magnitude of velocity becomes constant.
Speed remains constant.
Speed remains constant, not the velocity alone. Velocity direction keeps changing, right? So therefore you should not say velocity is constant. Velocity changes due to direction. That is always there in a circular motion. So what remains constant? Speed will remain constant. Non-uniform motion, alpha is not equal to 0. At will not be equal to 0. And therefore, V keeps on changing. The magnitude of V keeps on changing or varying. Okay. And in this case, it's going to be, you have to consider both the radial acceleration and the tangential acceleration. Whereas in the case of uniform motion, you will only have to worry about the radial acceleration, which will be v square by r. Easy to deal with. Mostly for the CET, they only ask you about uniform circular motion. Very rarely you will find non-uniform circular motion being asked. Okay. If you all are done okay with this, I think I have completed whatever I wanted to tell you about the two-dimensional motion. Now we can take up problems, questions, MCQs for solving.
Okay, sir.
Okay. Are you all okay with this? Students, can I move on?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Explain relative velocity.
Sorry, sir.
Relative velocity.
Relative velocity, I think yesterday I told you some parts of it. Okay, if time permits today, after this discussion, I will give you some more hints about relative velocity. All right. Otherwise, I want to generally skip that part from this. Not much questions come, but I can discuss this if the time permits after this questions. All right. Thanks for reminding that. There are so many things that I can't really do it because of the time constraints. I think you will all understand that part. Okay.
Yes, sir.
A projectile is projected at an angle of elevation alpha with respect to the horizontal. After t seconds, it appears to have an angle of elevation beta with the horizontal as seen from the point of projection. The velocity of the projectile is. Okay, a nice question. I have to find out what is the velocity of the projection for this particular case. Nice question. Let's see how to work out this. What is that I have to find out? I hope the diagram will be clear to you all. I have projected with a velocity u at an angle alpha. Then it actually has a projectile motion like this. Now at some point here, it will have velocity v. And it is known that this is basically making an angle of beta. Making an angle beta. Okay. Now I have to find out what is the velocity of projection u. That is my major concern. Okay. I have to write that in terms of alpha and beta. Look at it. I really don't have any other option but to write down this u in terms of this, given this particular information. T is known, so I can also express in terms of t. Not very difficult, dear students. It should be done quite easily. Here we will say that ux is given to be Vx rather is given to be V cos U cos alpha. U cos alpha. Similarly, Vy will be equal to U sin alpha minus GT. Minus GT. But what is Vx and what is Vy? Vx is essentially, so this is U, by the way. This is U. I'm reiterating. This can be written as V cos beta, and this will be equal to V sin beta. That is Vy will be equal to V sin beta. Now together I can write this as I can write this as where do I write? I think I'll write it here. Just give me a minute. Yes, let me write it here. Now, if I divide one by the other here, I get this to be tan beta is equal to U sin alpha minus GT by U cos alpha. U cos alpha. Am I right? Now I can write down this tan beta as sin beta by cos beta. There's lengthy of calculation here to do it. So hold on and then make sure that you follow whatever I'm doing here. This into U cos alpha. Now I can interchange these two and write it as U cos alpha sin beta is equal to U sin alpha cos beta minus GT into cos beta. GT into cos beta. Now interchange and write this as GT cos beta is equal to U sin alpha cos beta. Now take this to the other side. You get this to be minus U cos alpha sin beta. And after this, I'm sure students, you'll all be immediately able to tell me what is this sin alpha cos beta minus
Sin
cos
alpha minus beta.
Very good. Sin alpha minus beta. So can I not get the expression for U now? So therefore U, which is the velocity of projection, is given to be GT cos beta divided by sin alpha minus beta. Extremely nice question, isn't it? Where You are tested about many things here and then asked to finally get the answer. So the answer for this basically will be gt cos beta by sine alpha minus beta. So third one should be the right option for this. Good. So first itself, we could actually do a good question. Did you all write down this? Can I go to my second question? If you all have written down this.
Yes, sir.
Thank you.
Yes, sir.
Yes, sir.
Yes, sir.
Question number 2.
Sir, was the first question CET question?
It's on a little higher side, but many times in the last 2-3 years, especially, questions of this kind has come. Okay, especially last 2-3 years, they have increased the level of the CET almost to that of the mains level, because once they started following CBSE NCERT book for a long time, now they feel that the students are capable of going to this level. So this can be of a variety where it can surprise you by coming. And in two-dimensional motion, these are the kinds of problems that you should really be ready for. Okay?
Thank you, sir. Thank you.
It's just the mathematical rigor, that's all. But otherwise, it's almost a question which can be done easily.
Thank you, sir.
A particle covers 50-meter distance when projected with an initial speed. On the same surface, what distance will it cover when projected with twice the initial speed? Very interesting. What is range proportional to? Range is proportional to u square, isn't it? Yeah, and therefore I get this to be, if you now double this velocity, so what will range be? Range will be, or I can say that R1 by R2 will be equal to u square by 4u square, and therefore R2 will be equal to 4 times R1. 4 times R1, R1 is given to be 50 meters. So 4 into 50 will be 200 meters. Option 3 for this question. Simple one. So one we had a little tougher one. Second one was actually a nice one. Question number 3. Let's see how to do question number 3 now. From the top of a tower of height 40 meters, a ball is projected upwards with a speed of 20 meters at an angle of elevation 30 degrees. What is the ratio of the total time taken by the ball to hit the ground and the time taken by the ball to come to the same level as the top of the tower? Very nice question. I'm taking some questions, in fact, here to be on a little higher side, because you can basically get to know few ideas in a short duration of time. Otherwise, I should have done 5 questions like this to get to all the ideas that this particular question carries. Okay. Now, what is it done? From a top of a tower of height h equal to 40 meters, it is projected with some velocity of 20 meters with an angle of 30 degrees. Angle of 30 degrees. It's going to be like this, all like this. Now they're asking you to find out 2 times. The time taken up to this point, let's call it as T1. The time taken to reach the ground, let's call it as T2. They want you to find out what is T1 and T2. T1 is very simple. T1 is like ground-to-ground projectile, isn't it? It's like ground-to-ground projectile, because to come to the same level, look at it, it's almost like ground-to-ground projectile. So I can use the expression 2u sine theta by g. I have everything with me now. 2 is u is given to be 20. Sine theta is sine 30, which is known. Take g as 10. So you will get T1 therefore to be equal to half. So 20 by 10 is equal to 2 seconds.
2 seconds.
Now the second part is what is very interesting. Look, I have done one ground-to-ground projectile with a time of flight. Now I have to find out T2. I told you how to find T2 when I was discussing. That is why I told you it's important that we remember that. So I'll be referring to that directly and writing down that. Minus 40 should be equal to u sine theta into T2 minus half 10 into T2 square. Directly I'm writing it. Okay. I think you will all be able to appreciate this. This will be 20 into sine 30 will be half T2 minus 5 T2 square is equal to minus 40. Now solve this quickly to get the answer for. So this will be 10. I'm now going to write this as 5 T2 square minus 10 T2 minus 40 is equal to 0. Prajwal, mute their mic. 2 T2 minus 8 is equal to 0. Now solve this quickly to get what T2 is. Okay, what T2 is. You will find that T2 will be written as 2 plus 6 divided by 2, which will be equal to 4 seconds. 4 seconds. Solve this, you will get. Not really difficult to do. You can very quickly do it. You can factorize and do it because it's that simple. Okay, you will get T2 to be 4 seconds. Now, moment you get T2 to be 4 seconds, I have to find the ratio of the two. So ratio is T2 by T1, which will be 4 by 2, which is therefore 2:1. 2:1. So the answer to the third question, hence, will be 2:1. 2:1. Again, you may immediately ask me whether people are going to ask this kind of question in CET. Why not? Okay, because these are all the things that you already do in your PU stuff, and therefore this is a question which can definitely be asked. Can I go to my next question?
Yeah, yes, sir.
Yes,
Sir,
sir.
can you put the page a bit up? Can I take a screenshot of it? Thank you, sir. Thank you.
Question number 4. A particle is projected with an angle of theta to the horizontal line passing through point P1, P comma Q, and Q comma P, referred to the horizontal and vertical axes, can be treated as the x-axis and the y-axis respectively. The angle of projection can be given by. Angle of projection can be given by. A nice question, isn't it? Fourth question. Let us see how to do this. Now, a particle is projected on angle theta to the horizontal line passing through P comma Q. Now, P comma Q means x is equal to P, y is equal to Q. And therefore, I can say Q square should be equal to tan theta P minus G P square by 2u square cos square theta. All right. Now, you also have another equation that it passes through a point Q comma P. It also passes through that. So therefore, what can I write it as? I can also write it as, because it passes through the other point, now x will become Q, y will become P. So you will also have an expression for P square is equal to tan theta Q. All right, tan theta Q. Are you all getting it? Tan theta Q minus G Q square by 2u square cos square theta. Now I have to basically get the expression for the angle of projection. So I have to find out what this theta is. So the way that I'm going to go about is by writing this two expressions. Okay, this expression and this expression. Look how I'm going to write it as G P square by 2u square cos square theta can be written as Q square. Okay, Q square or rather P tan theta minus Q square. Similarly, G Q square by 2u square cos square theta can be written as Q tan theta P minus P square. I just interchange these two expressions here and then got it. Now let us divide one by the other. If I divide one by the other, all this G u square cos square theta will go away. Then what am I left with? If I divide one by the other, these two, divide one by the other, then I get this to be P square by Q square is equal to P tan theta minus Q square divided by Q tan theta minus P square. minus p square. Now, if you do all this, you will end up getting an expression for tan theta. Simplify this, very simple, no big issue at all. You will get this to be tan theta is equal to p square plus pq plus q square divided by pq. You can just simplify this in this way, and then you get the expression for tan theta like this. You can work it out and then check it out. So I've given you the expression for it, how to do. I think rest of it can be done easily. Because I've eliminated u square cos square theta, that's a big thing. The moment you eliminate it, rest of it becomes simple. Okay. If you're all done with this, then I'll go to my next question, which is the fifth one.
Sir, option A. Sir, option A is the answer, sir.
Option A is the answer, sir.
So option A is the answer.
Thank you. I marked it as the other one, is it? Okay. No, by chance I did that. Okay, I think you're right. One is the one, but I think the answer is all right. No, tan theta is equal to plus p square q square by p. Correct. But a nice question. Huh? Nice question. It's equation of trajectory tested to the core. A bomb is dropped from an aeroplane moving horizontally at constant speed. When the air resistance is taken into consideration, the bomb will. Nice question. Let me see. What do you all think? If the bomb is dropped from an aeroplane moving horizontally at a constant speed, the air resistance taken into consideration.
Fall to the earth when the aeroplane fall to the earth as the airplane flies with the wrong falls.
Read all the
B.
options.
B.
Read all the options and see what you get for
Second option.
Second
Option
option.
2. Option 2, sir.
Option 2, sir.
It falls
Two, sir.
behind the aeroplane. Falls behind the aeroplane. Very nice. Because I'm considering the air resistance. Okay, air resistance. Otherwise, the bomb would have dropped exactly below the aeroplane. What is that I say? Okay. Now for the sixth question. The maximum and the minimum velocity of projection are 10 meter per second, 20 meter per second respectively. The horizontal range and the maximum height are respectively. Okay, now you have one velocity given to be 10 meter per second, the other one to be 20 meter per second, maximum and minimum. Now we have to find out what will be the horizontal range and the maximum height. Horizontal range and the maximum height. Very nice. Okay. Minimum and the maximum velocities of projectiles are 10 meter and 20 meter per second square. How do we do this?
Option C.
Okay. So now when we have minimum, u minimum. So u minimum is u cos
Option
theta.
D, sir.
Okay, let's check it up. Will be equal to 10 meter per second. Okay, and the vertical component here should be equal to 0. Okay, then when you say u maximum, that will be equal to 20 meter per second when it is projected vertically. All right, 20 meter per second. So therefore, the range which is given to be u square sine 2 theta by g. Okay, sine 2 theta by g. And what is the expression for the height? The height attained will always be equal to u square sine square theta by 2g. And now I can say that u cos theta by u will be equal to 10 by 20, and therefore it will be equal to half, or theta will be equal to 60 degree. So since theta is equal to 60 degree, I can find out what the range is. The range will be equal to u square sine 2 theta by g. By the way, this can also be written as 2 u square. I told you, no, that time this will be a very useful one. Sine theta cos theta by g. Now the problems here are appearing to be a little challenging. I want that to be like that, because in the projectile motion, these are the kinds of problems that you will find it difficult to solve. So therefore, I'm taking it up and then solving it for you. Cos theta sine theta divided by 10. So simplify this, you get this to be 20 root 3 meters. 20 root 3 meters. Similarly, now how do I find the maximum height, or the height attained by the projectile? H will be equal to u square sine square theta by 2g, which would be 20 square into sine square theta will now be equal to sine 60. So it is root 3 by 2, the whole square, isn't it? Sine 60 divided by 2 into 10. Together, this will turn out to be 15 meter. 15 meter. So the answer therefore should be 20 root 3 and 15. 20 root 3 and 15. So the answer to this should be second one. 20 root 3 and 15.
Yes, sir.
Yeah. Going to be quite a challenging one, isn't it? Okay. Because of this idea being given here. So good. We have done up to 6th. Can I now move on to my next set of questions, if you all are okay with it?
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Sir.
Question number 7. Today the problems, in fact, are all on a higher side, but let's see. Two particles A and B are projected in air with a velocity of 10 meters per second. A is thrown horizontally and B is thrown vertically up. What is the separation between them after 1 second? Okay, that is what is to be obtained now. Let us try to do it. Not very difficult to do, because you just have to find out the separation between them after 1 second. You will find that y1 will be equal to y1 is when it is basically projected horizontally, isn't it? It is thrown horizontally. Then for horizontally thrown, y1 will be equal to half gt square. Now after 1 second, so half g is 10 into 1 square. So what will I get this to be equal to? Minus 5 meter. Minus 5 means what? Actually, if you consider a particle from where it is thrown, it has come down by a height of this, and this is your y1. This is your y1. Very good. Now the other one is particle is thrown actually upward with a velocity of is thrown vertically up with the same speed, 10 meters per second. Now this will also keep rising up, and what will be y2 is the question in 1 second. So y2 therefore will be equal to this is from your 1D motion, 10t minus half gt square, which will be equal to 10 into 1 minus half 10 into 1. So this will turn out to be 5 meters. 5 meters. So what is delta y therefore? Delta y, which is the separation in the y, which will be equal to y2 minus y1 will be equal to 5 minus of minus 5 equal to 10 meter. Very nice question, I would say. Delta y is 10 meter. Now what about delta x? Do we also have separation there? We should expect that there should be a separation, especially for the first particle. Second particle, x coordinate. For the first particle, there will be x coordinate, which will be equal to 10 into 1, which is 10 meters. Whereas x2 will be 0 because it's projected vertically up, isn't it? So x2 will be 0. So delta x also will turn out to be 10 meters. So the particle is somewhere here, and you have to find out what is the separation between the two. This separation is what they're asking you. I know delta x. I know what delta y is. I know what delta y is. I have to find out the separation between the two, which is yes. Yes, therefore, will be equal to root of delta x square plus delta y square. Look at it, all the things you have studied, nothing is new here. Okay, and therefore this will turn out to be 10 square plus 10 square is equal to 10 root 2 meters. So therefore, what is the answer for this? Answer should be the second one here, which is 10 root 2 meters. I would say again, a very interesting problem, and I love this kind of questions. You should all get ready for solving questions like this. You will then be able to beat the others. When a body falls from an aeroplane, there is an increase in
Kinetic energy.
Kinetic energy.
What about acceleration?
Acceleration is constant, so gravity.
Very good, is equal to minus g. Very nice, I say. What about potential energy?
Potential energy decreases.
Decreases.
Decreases. Rest mass?
Potential energy 0.
Remains same.
No.
Constant.
Potential energy, as it falls down, it keeps on decreasing and becomes zero only when it reaches the ground. Okay, so it decreases. Only thing that increases is the kinetic energy. Okay, so therefore, analyze the questions when you are practicing like this. When you are in the examination, eliminate the answers and write the right one and go. Okay, but when you are learning it for the examination, look at what will happen to all other options. Why are they wrong? Because tomorrow that itself may be asked as a question. They can say when a body falls from an aeroplane, which quantity decreases? Then you can choose potential energy. Then you can say which quantity remains constant, then acceleration. Look at it, the same question can be asked in different varieties. So you need to actually look at them as well. Especially conceptual questions. Go through them in that way. Ninth question. A man is standing in a car moving with a speed of 54 meters per hour. Observes a man B in front of the car crossing perpendicularly a road of width 15 meters in 3 seconds. The velocity of the man is. Nice question. Ninth one.
Sir, this is about relative velocity, no sir?
Exactly, relative velocity. And someone asked me for relative velocity, and therefore this gives me an opportunity to also deal with it. So let me try and see if I can work it out for you. First of all, man A is standing in a car moving with a speed of 54 meters, observes a man B in front of the car crossing perpendicularly a road of within 15 meters in 3 seconds. So now what we know is that man B, okay, velocity of man B with respect to A is something that we know. He says that he is trying to cross the road perpendicularly.
VA minus VB.
VA minus VB is correct, but this will be 15 meter divided by 3 and therefore 5 meter per second. What you say is right. I agree with you. This will be essentially VB minus VA. VB minus VA. Okay, this will be equal to 5 meter per second. But let me tell you that this will be this is how it should be done. VB minus VA is given to be this. Very good. I completely agree with you. Okay. Then do we know what is the speed of A? Do we know what is the speed of A? Speed of A. Oh, by the way, when I write this one, VBA, I should also say that this should be along, let us say, I cap. Because if I say the road is like this width I will say is, oh, this will be J cap. Okay, fine, J cap. This will be I cap. So this will, I'll take it as J cap. Now, do we know what VA is? We know VA because the velocity of the car is going to be 54 kilometer per hour. What is 54 kilometer per hour in meter per second? Dear students, you should know how to convert that.
15 meter per second.
It's 15 meter per second.
15 meter per second.
How do we convert it?
Into 5 by 18.
5 by 18.
5 by 18.
18 ones are 18 threes.
18 threes.
So this becomes 15 meter per second I cap. Very good, very good. So VA is given to be like this. Now, what am I supposed to find out? What am I supposed to find out? I'm supposed to find out VB. Now, can I do it? Because I know what VB minus VA is. VB minus VA is given to be 5 minus 5 J cap, because this downward, no? So I'll take this as, also can be taken as plus, doesn't matter. Okay, take it as plus, doesn't matter. 5 J cap. Therefore, VB is VA plus 5 J cap. Please look at it. This should be done very carefully. Yeah, 5 J cap. VA is 15 I cap plus 5 J cap. 5 J cap. So what will be the velocity of B? Magnitude of the velocity will now be given as root of 15 square plus 5 square. Okay, 15 square plus 5 square, which will be equal to 5 root 10 meter per second. 5 root 10 meter per second. Now, what is the angle that it makes? What is the angle that it makes? Look at it. This is how VBA is. This is how VA is. But remember, VB will be somewhere around like this. I have to find out what is the angle that it makes with respect to I. So that can be written as tan theta equal to VBA by VA. VBA by VA, which will be 5 by 15 equal to 1 by 3. Nice question, isn't it? Tan theta therefore is 1 by 3. Let us see if some of the options basically matches with this. Some of the options matches with this. Do you remember VB is 5 root 10? The other one is angle is this. Okay. We have 5 root 10. Two of them. Towards the car at the same angle. No, it's not towards the car. It is away from the car. Can you see that? Away from the car. And therefore, it's 5 root 2 away from the car at some angle. It's not coming like this. It's going away from the car. Car is coming like this. Car is coming in this direction. So going away. So therefore, it should be 5 root 10 away from the car at some angle. Is this okay? One problem on relative motion someone asked me for.
Sir, in the 7th question, can you explain how did you take Y1?
You mean 8th question?
7.
7th. Okay, 7th. Y1, look at it. This is basically a projectile being thrown at some horizontal angle. I mean horizontal like this, and it's coming down like this, isn't it? So this is where I have to consider Y1. Y1 is simply the motion along the Y direction. Along the Y direction, it should be UYT minus half GT, UYT minus half GT square, right? UY is 0 because initial velocity is only along horizontal. There is no vertical component. And therefore, Y1 will be equal to minus half GT square. All right?
Yes, sir. Thank you so much.
Yeah, you're welcome. I think we'll just have time for 1 or 2 more questions. We'll not do all of them. I want to give you at least some 5 questions as homework. So I'll do 10 questions and leave another 5 as homework and also give you the solution for them. Okay. I'm now going to my next page to answer 1 more question. Yes, tell me, sir.
Sir, actually, I'm sorry to be asking so late, but in the 3rd question, sir, the way you calculated T2, I think you've calculated T2 from 40 meters while it falls. So the T2, whatever they had asked was total time.
Yeah. I will go back to that. I have calculated from this point to this point what T2 is. Okay. I didn't calculate from this point to this point. I calculate from here to here. I know what your confusion is. I know what your confusion is. If you had come for my yesterday's class, I told you for the motion, it's only important is initial and the final point. The way it reaches, I don't have to even bother about. It goes here and comes like this. I do agree. But I've taken the initial velocity to be equal to 20 sine alpha in the upward direction. If your analysis were to be taken, then if I started from here, I should have taken this to be minus 20 sine theta. I took it as plus. Yeah. If I take it as plus, then I calculate from this point to this point. If I take it as minus, then I calculate the time taken from this point to this point. Is this idea clear? It's a nice curve. It's a nice doubt. Fantastic. I really, really appreciate this doubt. But I hope I made this point clear to you.
Yes, sir. Yes, sir.
Yeah.
Thank you. Thank you very much.
Thank you. Which school are you from? Which college are you from?
Sir, Vidyaniketan.
Oh, I see. Okay, 10th question. 10th question. Two similar trains. Two similar trains are moving along equatorial line with the same speed, but in opposite direction. They will exert equal pressure on the rails. This is something to do with your circular motion. In a uniform circular motion, the magnitude of acceleration remains constant, but the direction continuously changes. Two trains are moving along the equatorial line with the same speed, but in opposite direction. They will exert equal pressure on the rails. Why is this given? Why is this given? If you consider Earth to be rotating here like this, okay, Earth is rotating in this way, and if the train is also moving in the same direction, the net velocity, angular velocity of the train 1 will be the angular velocity of the Earth plus the train. If this is the case, then we know that there will be what is called as centripetal force. The centripetal force will be equal to m omega 1 square into r, where r is the radius of Earth. Radius of Earth. This is for the train moving in the direction of the rotation of Earth. For the train which is moving opposite to that of Earth, if Earth is rotating like this, and if the train is moving opposite, then omega 2 will be equal to omega e minus omega naught. So F2 now will be equal to m omega 2 square r. You can easily see that F1 will be greater than F2. So they will not exert the equal pressure. They will exert unequal pressures because of the centripetal force. So hence, my assertion seems to be false. F1 is greater than F2. Assertion is false. In which option do you have assertion being false? Assertion being false.
Fourth option.
Fourth option.
Okay, let us see. In circular motion, the magnitude of assertion remains constant, but the direction continuously changes. Correct. What I think it says is correct, but in no way related to the assertion that we are making. Okay, assertion we are making. And therefore, a fourth one is the correct one. Assertion is false, but the reason is true. Now you may be wondering, do we have assertion and reason kind of question? No, not in CET. But NEET can be surprising if they can ask a question like this. Many times what they do is, instead of assertion and reason, they make it as statement 1 and statement 2. And statement 2. Then they can ask a question if statement 1 is true, statement 2 is false, and so on and so forth. Is one the reason of the other? So that kind of question can definitely be asked in CET, and it has already come many a times. Okay. I think with this, shall we end today's discussion? I hope it was useful. We could do some really, really nice questions, and I think it benefited all of you.
Yes, sir.
Was it okay?
So,
Yes, sir.
Yeah, tell me.
Yes, sir. Thank you.
So again, I want to repeat to all of you, we will have mathematics class at 11 o'clock. It will start sharply at 11 o'clock and it will be there till 12:30. After mathematics class, there will be a break of some 3 to 4 days for your English examination. We'll meet only after the English exam. So until then, all the best for all of you. Do well in your English examination. Those who are aiming to be within 10 rank or 100 rank in the PU board, take English seriously, study properly, and then make sure that you clear that examination with flying colors. Okay. So with this note, and also I hope that you will all utilize your time properly. All the best and goodbye.
Thank you, sir.
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 Thank you, sir.